Hi guys. So today we will continue talking about oxidation reduction reactions, or what we call redox reactions. And in today's lecture, the objective is to use a method that we call it the half reaction method in order to balance oxidation reduction reactions that take place in aqueous media. Just a quick reminder for you that we mentioned before that oxidation is loss of electrons. So if we have this hypothetical example here, we say A converts to A plus and it loses 1 electron. This is the oxidation half reaction. And at the same time, B gains an electron to give the negative anion, or the anion, and this is the reduction half reaction. The overall reaction, we get the overall reaction by combining the two half reactions. Well, like in this reaction, as we notice over here, is that 1 electron is gained by B and another electron is lost by A. So when we add those two reactions, the 2 electrons will cancel out, or the electron will cancel out from both half reactions, and we will get the overall reaction as we notice over here. Now, one thing we also mentioned the other day is that once you get the overall redox reaction, we want to check for the total number of atoms on the left side should be the same as the total number of atoms on the right side of the equation. And here we have one A and 1 B. Here we have 1 A and 1 B. Also, we have to check for the total charge. The total charge on the left side, this is neutral, it's 0. B is neutral, so it's also 0. A positive, it has positive 1, and B has negative 1. So adding a positive 1 and negative 1 will give us 0. So this equation is also balanced with respect to the total charge. We also mentioned the other day that there is no oxidation reaction without reduction and no reduction without oxidation, meaning that both of them have to take place at the same time. And also, we cannot have a redox reaction that has 2 oxidation reactions or 2 reduction reactions. We have to have one of each type. Also, as we have noticed over here, is that the overall redox reaction should not contain any electrons. And in order to balance any given redox reaction, the tools that we will use today are electrons, hydrogen ions, and molecules of water. So let's see how we will use all of the information that we have in mind right now in order to work an example to balance a redox reaction. So the example here says that balance the following redox reaction that takes place in acid medium. We know that in acid medium we have hydrogen ions. So this is a reaction between the dichromate ion with the nitrite ion to give chromium 3 plus nitrate ion. This equation, as we notice over here, is that it's unbalanced. So to balance it, we start by breaking this reaction into 2 half reactions. How do we do that? The dichromate is related to chromium, so that will give us the first half reaction. So that this is the dichromate here, and that converts to chromium 3 plus, and that is the first half reaction. The second half reaction will include the nitrite ion converting to the nitrate ion. So now what we need to do, we take every half reaction and balance it by itself. And then once we are done balancing the first one and balancing the second half reaction, then we will combine both of them, as we will see here in a minute. So let's take a look at the first one. Here is the dichromate ion, and that converts to chromium ion, chromium 3 plus, as we see here. So now take a look at this. We have 2 chromium atoms on the left side, then we have to multiply this by 2. So we are done with balancing the chromium atoms. Now here we have 7 oxygen atoms on the dichromate, but no oxygen atoms in the chromium 3. Remember the tools that we mentioned about? We use molecules of water or hydrogen ions or electrons to balance the equations. So those 7 oxygen atoms will come as molecules of H2O. All right, so this is all of them will come as molecules of H2O, and in that because there is only 1 oxygen atom in every molecule of H2O, then we need to get 7 H2O molecules. Now the next step is that in order to form those 7 molecules of H2O, we need to add a number of hydrogen ions on the left side. So 7 times 2, it's 14, then we need 14 hydrogen ions on the left side. So this equation is now balanced with respect to the total number of atoms on both sides. The next step is to balance it with respect to the total charge. So let's take a look at what is the total charge on the right side. We have 2 chromium 3, so 2 times positive 3, that is positive 6 on the right side. And this is 7 molecules of H2O, that is 0, so the total charge here is positive 6. Now take a look on the left side. The dichromate ion carries 2 negative charges. And again, don't get confused, as some of you might do it, multiply 7 times negative 2. If you think that you might get confused, then use brackets like that to show the 2 electrons, the 2 negative charges on all of the 9 atoms together. So this is negative 2, and here is positive 14 for the 14 hydrogen ions. So the total right now is positive 12. Now, how can we convert positive 12 to positive 6? That means that requires us to add 6 electrons on the left side of this half reaction here. So in that case, this equation is balanced with respect to the total atoms on each side and also the total charge. So this will give us, this will be the reduction half reaction. All right, and remember this consumes 6 electrons. Then when we balance the conversion from nitrite to nitrate, this half reaction should produce electrons. Because if this is the reduction, then the second one here has to be the oxidation, and the electrons in the oxidation half reaction have to be products on the right side of the half reaction. So let's take a look at how we can balance the nitrate half reaction. So here is what we will do. Get again the nitrite ion on the left like that, converting to NO3. And let's see, we have 2 oxygen atoms here, we have 3 oxygen atoms over here. So we need to add 1 oxygen atom to this side. The source of the oxygen atoms will be, like say, a molecule of H2O. So adding 1 molecule of H2O will add 1 oxygen atom to the 2 here. So that will give us the nitrate ion. At the same time, it will produce 2 hydrogen ions. So that makes this equation balanced with respect to the number of atoms on the left side is the same as the number of atoms on the right side. So now we need to balance it for the total charge. Remember what we said over here, this half reaction consumes electrons, then this one has to produce electrons over here. Let's see how we will prove that. The total charge on this side is -1 for the nitrite ion. Water is neutral, so this is -1. On the other side here, the nitrate ion is -1, and we have 2 positive charges for the 2 protons here. So the result here is +1. So what do we need to do? We need to convert +1 to -1. And the only way that we can do this is to add 2 electrons on that side. So that will balance this. This will be the oxidation half reaction. All right, what's next? The next step is to add those 2 half reactions. But remember what we mentioned earlier is that the overall reaction should not contain any electrons at all. This one consumes 6 electrons. This half reaction produces 2 electrons. Then we need to, like say, multiply this equation by 3 in order to make the number of electrons in the oxidation half reaction the same as the number of electrons consumed in the oxidation one before we add the 2 half reactions together. When we do that for this half reaction, it will look like that. Will be 3 of the nitrite ion plus 3 molecules of H2O. That will give 3 ions of the nitrate ion plus 6 hydrogen ions plus 6 electrons. All right, that will be the reduction half reaction. Let's get the dichromate, or this will be the oxidation half reaction. Let's get the second one. Put the dichromate here. Sorry. We get the dichromate plus the 14 protons plus the 6 electrons. That will give the 2 chromium 3 plus 7 H2O molecules, and then add those 2 half reactions here. Now we've got to be careful with, because we have more than one thing that will cancel out here. First of all, we'll cancel out the electrons as we see over here. The second is that we notice that this consumes molecules of H2O and produces hydrogen ions. At the same time, this consumes hydrogen ions and produces molecules of H2O. So let's see if we can also get rid of the molecules of water and also the hydrogen ions. We have 3 H2O here, so this will cancel with 3 of those, and we'll end up having only 4 molecules of H2O. Now here as we have 6 hydrogen ions, this will cancel with 6 of this, we'll end up having only 8 hydrogen ions. So when we add those together, it will show like 3 of the nitrite ion plus 1 dichromate ion plus 8 protons to give on the other side 3 of the nitrate ion plus 2 of the chromium 3 plus 4 of the H2O molecules here. That is the overall reaction, but we need to check again for a couple of things as we mentioned earlier. The total charge should be the same on both sides, and also the total number of atoms on both sides of the overall equation should be the same. So if we look at the total charge on the nitrite ion, this is -3. The dichromate is -2. 8 protons is +8. And on the other side here, -3 for the nitrate, +6 for the chromium 3. So this overall will be +3. On this side, this will be -5 and +8. So that should give us +3 as we notice here. So the number, the total charge on the left side is the same as the total charge on the right side. Now, in order to check for the atoms, we can do this by inspection, but I would like for you to use this like small table. You can do it and get it quickly. Whenever we have more than like say 2 or 3 atoms, it would be a good idea to use this table here in order to make sure that the equation is also balanced. So right, like here is the species, and this is the left side of the equation, and here is the right side of the equation. So what do we have on each side? Here we have nitrogen, we have chromium, we have hydrogen, we have oxygen, and we have the total charge. So for nitrogen, what we notice here, we have 3 nitrogen atoms on the left side. We have also 3 nitrogen atoms on the right side. Chromium, we have 2 on the left side, we have 2 on the right side. Hydrogen, we have 8 of them on the left side, and we also have 8 in the H2O molecules, 4 of them. For H2O will contain 8 hydrogen atoms. And the last thing is oxygen. We have here 6 plus 7, that is 13 on the left side. On the right side, we have 3 times 3, that is 9, plus 4, so it's also 13. And finally, the charge here is +3, and also +3 on the right side of the equation. I hope you got that example here. That will end our lecture for today. Next time, we'll be talking about balancing redox reactions that take place in basic medium, where the medium has hydroxide ions and not hydrogen ions. Thank you for your time, and have a great afternoon.